Okay, Twitch. Let's see. Let's make a new window. This is gonna. Oh, it popped up in the right place. That's great. I'm kind of unprepared today, so I'm gonna play some music. Come on, play the music. There we go. Is the music even playing? It is. Ha 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 ha! It's all working. Except now I need to pull up my dashboard. This isn't the first song on this album. What are we doing? Yeah. No, it needs to go back here. There we go. Okay. Stream manager. Loud. Okay, there we go. Well, friends, we're gonna see how long we stream for today. At most, I'm gonna do an hour. I guess I can tell people that I'm streaming. I don't know. Let's see. Yeah, I have a busy day in front of me today, so at most I will be streaming for an hour today. Okay. I think this might be fun for me to try to break down what the hell's going on here. I'm stuck. I streamed this weekend for those of y'all who missed it. Let's see. Hold on one second. Do I not have a... Okay. Cool. So I streamed this weekend for those of y'all who missed it, and we've gotten to a place where I have no idea why the delay is not working properly. My ads are about to start. Let's go ahead and run that, because ain't nobody here yet. Yeah, so I don't know why this delay isn't working, and it's driving me nuts. And I have two options today. And I think... Who you calling nobody? You're nobody. No. Well, and you're nobody who's going to get ads, so... Because you're subbed. Okay, so here's where we laid off over the weekend with this delay. And when I stream, which will not be until I'm going to miss the next two scheduled times at the best, probably the next three. So I probably will be off stream Thursday, Tuesday, and Thursday again. Life things. When I get back, unless somehow I solve all of my problems in the next hour. That's weird. The channel pointer isn't used. Okay. Unless I solve all of my problems in the next hour, I think when I get back, I'm going to ditch the delay, and we're going to work on a compressor, because I can work on a compressor, and there's some neat things that I can do with that. Let me see. I'm going to crank the volume of the music down a little bit because it seemed like it was a little loud. Let me know if the music's too quiet or too loud, please. But for now, let's walk through the delay code together. And then I will see if today I see something that I did not see last time. So what we did last time was over the weekend, I pinpointed the problem. So what's happening right now? Let me, I guess it would actually be useful if I built and you get to hear it. Let's do that. One moment, please. Okay, so I'll set up a tone generator. Turn that off. And I'll pull up the plugin. And now what I want you to do is just listen. Terrible, right? Horribly awful. Super bad, awful noises. What's up, Hagerman? How you doing, sir? So we was working on this over the weekend, and where I left off is that the pain point, like what's going wrong, is here. Well, let's say it's not. Let's see if I can make a better way to describe this. Yes, that is even beyond aliasing. What it sounds like is, I think it's. This doesn't make any sense. This is why I'm struggling with this. If I changed what we did last time is I set a default sample delay time, right? So at one point I had set this to half a second. If I set this to half a second delay, I get a different tone. Like it'll still be awful sounding, but it's a different tone, right? And then setting this to 100, I get the tone we just heard. And if I set it to one sample, it sounds perfectly fine. What that says to me is it's like it could be a phasing issue, but that doesn't make any sense. And maybe I'm like going down some sort of weird rabbit hole that I don't know. But where I was convinced something was happening last time is all that I'm doing here is we get the read position. So the wave sounds squared off. Yeah, for sure. So what we're doing is we're getting James, you understand the concept of a circular buffer, right? Do I have to explain that? Or Hagerman? Do I need to explain the concept of a circular buffer? And now I wait to get feedback from y'all. We will find out if you understand. I think I get it. Okay. So essentially, a circular buffer is it's a set of samples. Let me do this in a comment. Shall I redeem the bad code editor again? I mean, you do what you want. Might make me cry, but sure. It's fine. Okay, so we've got, this is an array or a buffer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, again, the channel points there are for you to you either get to decide whether to torture me or not. So we've got 10 positions here. Okay, so this is position 1, that's position 2, so on and so forth. Okay. This is called an array in programming. This is also called a buffer, is another way of saying this. So when you watch Netflix and it says that it's buffering, it's trying to preload data onto your TV to read it in a way that doesn't require more loading. So it like Netflix needs to load enough video data that it seems seamless when you're watching it, but what's going on is it's constantly loading additional blocks of data in the background, right? So what we do with a audio buffer, an array of audio, is James, you'll probably be familiar with the Pro Tools block size and having to set that bigger or smaller depending on if you're using like reverb or something that's memory intensive or not. What you're doing is you're setting the amount of samples that get read by the digital audio workstation at one time. So in our case, for our dumb example here, we've got 10 samples. Okay. Typically that's like 512 or 2048 or whatever multiple of that, right? But for our little example here, it's going to be 10 samples. So each of these samples has a value between usually +1 and -1, and that's your compression rarefaction value for your speaker cone. And sometimes it's between 0 and 1, but it's typically -1, +1, right? And what we do is we have to write the samples into the buffer first, into the array, and then we read them, right? So it's just like a timeline. Like if my cursor right now is the timeline, I write all the samples one by one, and then once the samples are written, I have to go read all the samples one by one. But since what we're doing in a DAW is it's real time, we have to read and write simultaneously. So what has to happen is writing has to go first, right? Or has to the write head, essentially, if you think about it that way, has to be ahead of the read head. So we have to have a set of data that's already written to be able to read it. But since we're going in chunks of, 512 or whatever, what happens is we write all the data to our 10 samples here. And then once that's written, we go back to the first sample and we write more data. And then we go back again and then we write more data, right? And as we're going back and writing, and it's not this exact way, we're also reading behind the write. Have I lost any of you yet? Because this is the most complex part to follow. They don't happen write then read. Read and write happen at the same time, consistently. Does that make sense? I hope so. So the read and write loop over the same static set of samples over and over and over again. And for a delay, what we have to do is to make a delay effect, the size of your delay buffer, the delay array, has to be equivalent to the max potential length of the delay that you want or higher. So if I wanted a max of 4 seconds delay, I need to have 4 times the sample rate of position. I need an array that is 4 times the sample rate, right? Because sample rate is 1 second of audio. So 4 times that gives me 4 seconds on a delay, right? So I'm going to take in small chunks and write those to a much bigger, at least 4 second long array. And we're going to write to that array and read out from that array at the same time. And then once we have reached the end of that 4 second array, we loop back to the beginning and start the process again. But the problem is I have to hold a read position and a write position at the same time. So that's fundamentally how a delay works. So what we do is we build the read position off of the write position minus the amount of delay. So if we have a 1 second delay and we are at write position 44,100, then our read position is going to be at 0, right? If it's a whole 1 second. And so we get the right position, where we get the read position based off the right position. The right position is defined in another spot. And then we have to confirm that that position is a safe spot in the array to actually read from, that we're not out of bounds in any way. And so that's what we're doing here. And then we go and get our sample number. Interesting. Okay, yeah. We go get the actual sample from the read position itself. So what we're doing is, in this case, I got to the point where I hard-coded an array for left and right, rather than trying to do just some crazy multi-channel array stuff that I was doing earlier. So I'm like, okay, what I want to do is I want to read the delay array from this position, and I want to put that and take that number, whatever it is, the positive negative one number, and put it in read sample, right? So, and to actually write to that, or to actually read from that array, I need to write content into it, right? And so when we're writing content into it, what I'm doing is I'm taking the sound, or the value of the current sample of the array that the dog gave me, and I'm putting that in the right position. So what's going to happen is this write happens, and then eventually this read happens from that right position about, well, right now, 100 samples later. So what's happening is, when I read out of here, I then go use this here, because I'm changing the existing sample to the thing that I read. And I'm saying, play this out now. And it's getting really mad at me when I do that. And I don't know why. It makes that horrible sound. Hold on, I'm going to walk away for just a second, because I realized it's lunchtime and I should grab a protein shake. Okay. Have I lost any of you yet? I'm sure that I have, because I just explained a mildly complex topic. Essentially, if you think about making a delay in tape, this is what I have done, except it's in digital signal. And now I read sample code, and I read my previous old code, and I couldn't figure it out. No, I'm following more or less. Okay. So to me, what sounds like it's happening is that I am getting like fold back onto a signal, like that it's playing the existing signal and the sample, and the sample that I'm reading from, but that's not possible because this is a direct overwrite. So what we do is I get the this is the content that I get from the DAW. I get direct access to read to and write from it here, right? So DAW channel pointer turns into my direct sample-based access. Like I can access now sample by sample. It's definitely complex, but I do not have a strong audio-centric understanding, so smile and nod. Okay. Well, Hagerman, you'll probably understand the computer science part of this, the actual programming part of this, significantly better. Essentially, I can explain to you easily. If you're thinking about this from a programming perspective, I've got two arrays. I'm getting an array from the audio editor. That's 512 samples, 512 positions. I have an array that audio, the way that audio signals work is you have a thing called sample rate, and that's exactly akin to frame rate for video. But sample rate is significantly faster. So for audio sample rate to attach to video, it's just a number that's a standard stock number. It's a standard number. You usually want to have 48,000 samples per second be read. If it's not for video, then it's some multiple of 44,100 is like a CD based sample rate. So I don't remember why those two numbers were pulled together. Sky River probably knows better than I do off the top of my head, but we can always Google that too. But essentially, what I have to do is if I want to make a cool delay with a max delay time of 4 seconds, then I take a buffer in from the audio editor, an array in from the audio editor that's like 512 positions long. And then I'm holding in memory a different array that is a max of 48,000 times 4 positions. And so what I'm doing is I'm copying the data from the array that the audio editor gives me. I'm putting that data into my new significantly bigger array. And then I'm reading from that significantly bigger array and putting that data back into the original smaller array that the audio editor gave me. Because I'm taking its data, manipulating it, and giving it back. Right? It's exactly like if you're working in like Photoshop or something like that. A Photoshop plugin that if you did a black and white, you take data that the photo or video editor gives you, you manipulate it, you hand it back. It's the exact same concept. Human hearing cuts out at around 20 kilohertz, so the Nyquist frequency needs to be at least 40,000 kilohertz. Pushing it higher can reduce the risk of aliasing or of aliasing distortion. So yeah, you can go look up the Nyquist theorem, Hagerman, if you want to know more. So does that might make more sense in terms of my explanation from a computer science perspective on it? Yeah, exactly. This is like my daily life in my job. Is I balance explaining things from an audio perspective, which then I have to go like visualize an array, because when I talk to an audio person, they don't understand what an array or a buffer is, right? But if I explain it to you from a computer science perspective, you're like, oh yeah, I get it totally, because you're trying to think it's a complex situation with audio, and that's not true. And the audio person is thinking it's a complex situation with computer science, and that's also not true. It's just you overthink how difficult it is from your perspective, right? So essentially, what I'm doing right here is I've done a lot of that, but towards business facing folks. Yeah, exactly. Yes, exactly. So essentially what I'm doing, and now you'll follow me, Hagerman, is here's the buffer that I get from the DAW, from the audio editor, okay? And since we're in C, we're C++ land, I need to get a pointer, because a float pointer is an array. It's an array of floats, and it's pointing to the first sample in the array, right? So this now becomes the first sample in my array, and I can iterate through that now as if it's an array, right? So then what I'm doing is I'm reading from and I'm writing to that array in the same for loop. The read is just behind the write. And the first question you'll have is like, well, what happens if you haven't written data to a position yet? That's why you clear and zero out the buffer. So the buffer starts with every sample being 0. Every single position is 0, right? And so then I start writing to the array from the beginning of the array, but I'm reading from the array like 3/4 back, right? 3/4 from the end. So I read to the end first, and then I loop back around to the first position. Meanwhile, I'm writing starting from the first position and moving forward, right? So what happens is I'm doing all of that, but then the samples that I read, I overwrite the array that the audio editor is giving me. And when I overwrite that data, it's coming out as this crazy awful buzz. Does the buffer need pre-assignment of allocation at all? You mean like instantiation and zeroing out before doing work? Is that correct? Because that happens, yeah, that happens in a setup phase. So that's happening here. So this is a one-time call before any actual audio editing happens. So I've got like 3 different arrays here that I'm resizing and clearing, zeroing out, right? So all that stuff has to happen before playback happens, because if it doesn't happen before playback happens, that'll screw up playback. Congratulations. Now you can make cool audio things. Now you understand how it works. Like when you're developing a game, for example, all of this stuff is handled. This is like stuff a game engine provides to you, right? So you don't even have to think about music playback. You just go, here's music, play it, and it'll play it. But it's got a system underneath the hood that is handling this for you. So what I just had the thought of is, I think I might be barking up the wrong tree, but I'm going to set this delay time in samples to almost 1 second. Because I hear this thing that happens where I get a little bit of the tone properly before reading out from the delay. And it just sounds like the damn samples are corrupted. And I don't understand how that's possible. But I'm going to do this. I don't know that it's going to give me anything useful. Yeah, we're going to change this to 47,000. I don't know that this is going to give me anything useful, but I want to get more data. Yeah, I've touched scripts for modifying audio at runtime, but it's very elementary. Fade outs or picking from an array of audio clip sources and managing the triggers. Yeah, like I don't even know accurately how to do fade outs in signal processing. And even like modifying audio at runtime in a game is actually different than what I'm doing here in a lot of cases. Because what you're talking about, picking from an array of audio clips and managing their triggers, what I'm doing here is going, here, instead of here's the audio clip, play it back, I'm going, here's the audio clip, here's how to play it back, sample by sample, right? Like what I'm working on is you tell the game engine to play back, but what if you told it to play back at a different speed? What if you told it to pitch it down or something like that? In a game engine, typically they'll have a thing where you can just say, I want this to be pitched down. Pitch it down by 1. I'm writing the pitch down algorithm. But in this case, it's a delay. Okay. Yeah, I am in the lowest of low level programming for audio right now. OBS, that's right. This is kind of stupid. Every time I set up, or every time I restart Reaper, I have to reset the audio output in OBS of Reaper. Otherwise, y'all can't hear it. So, like, rapid debugging is kind of a pain in the ass. Oh, sweet. Glad that's becoming useful for you, James. All right, let me pause that so I can hear what the hell's going on. Okay, so this is going to sound awful, but how fast is it going to sound awful is the question. Instantly. Huh. Okay. So that was not what I expected, number one. And then number two, like, what's crazy is that the volume level increases. And I don't understand that because I'm not using any feedback at all. Like, I'm literally just overwriting the audio samples. Because buzz, buzz, buzz. I don't know what's going on and I don't know how to fix it, and this is frustrating the living bejesus out of me. But I will not quit. We will have a working delay. Okay. Let's pull up the sample code that I was working with a while ago and look through that one more time. Okay. So, Hagerman, this is where you would be useful. How much is the signal increasing after the delayed signal is introduced? It's not. Oh, wait, are you asking for an actual measurement, or are you asking what I'm doing in code? Because I'm not adding anything in code. At least that I'm aware of. Oh, I don't know. I can look. Hold on. I'm not gonna buzz your ears this time. I'm just gonna not add. We'll look at the VU meter, but we won't. I won't play it back for you. I made the right call, by the way, to get on stream today. I'm enjoying myself, which is good. I need that today. Okay. Let's look. This is not. Let's pull up the master meter, right? Because that'll give us a more accurate representation. Is that over my head? Let's see. There's my head on top of that. No. Okay. So we're at minus 12, and then oh, it reduces and comes back. Oh, weird. That time it didn't do it at all. Now I'm really confused. It sounds like the same signal is getting stacked on top of itself, which in case I'd expect an increase of 3 dB. That ought to be useful to know. Yeah, I mean, it sounds like it, but the meter the meter response on Reaper isn't fast enough. And it only happens... It only happens if I keep the tone generator running and then I bypass the delay and then I bring the delay back in, the volume doesn't change. So if the tone generator is running the whole time, the delay is not actually affecting the signal. Well, I don't know. There's something weird, man. Hold on. Let me make it so you can hear it. Hold on. Let me mute the music. Okay. Sorry for your ears. Okay, so there's your tone generator, right? That had a weird hitch to it. That had nothing wrong. But then if I do it Then you hear the stacking. It does look like it's about 3 dB. I'm even looking at the OBS meters. That's, I don't know, man. I'm super duper confused. Trust the meters then. You mean for the OBS stuff? Yeah, but I don't understand how it's stacking. Like that doesn't even make any sense to me because I'm not stacking it. I'm literally overwriting every single time. All right, let's look at the original example code. So they would do delay time and samples is whatever I said originally. That's fine. And then they went and built get interpolated sample time and samples. So I feel like last time I did this, I used their code for finding the proper position. So Hagerman, this is where you become useful if you're watching the actual code, because you will see things that I'm missing. So my read position is, come on, bring it back. They pull in read position, and then they check read positions less than 0.f, and then I do read position plus equals num samples. And num samples in this case is max buffer size. They have it as a double. I have it as an int. Whatever. That shouldn't matter. It hasn't mattered before. I'm tempted to change it anyway, but whatever. Then they get index y0 is int read position -1. That's just my read position -1. Then they check if that's less than 0, and then they do a plus equals again. But hilariously, they don't do the double there. So let's, I don't know, this shouldn't matter, but let's do that. What is K max channel buffer size? It's probably in the H file that I don't want to pull up right now. Okay, so where are we at? Where did we go? Okay, we're here. So reposition -1 is less than, yeah, okay, num samples. And then index of y1 is equal to read position, and that's my read position int is equal to integer read position, which I don't need to cast it because it inherently casts, but I am doing it anyway. Then read position integer is greater than or equal to number of samples. Okay. And then we have, yep, minus equals. So it's the same thing. Just different ways of writing it. Then we move into, they build the sample based on the read index. And then they go into getting linear interpolation going, and I'm not even bothering with that. Like, I have pulled that out of the equation. So, here, I am just instantiating read sample, and then we are reading from, we're just doing this. And then what I'm trying to do is write that out. Just as read. Now I'm wondering if I should try to bring back linear interpolation, but I was like, it's this that's failing. Yeah, I remember why I was so frustrated last time. So it's literally between the sample of Dodge channel pointer like, if I just make this, if I do this, I might lose the shit out of you, James, but we'll see. If I do, no, screw off. Then this is a bogus assignment. Like, I'm saying that 1 is equivalent to itself, right? Assign 1 to 1 or whatever, right? Assign what this already is to itself. If I do that, then I'm bypassing the whole effect and it sounds fine. Problem is, I'm taking that sound, right? And excuse me, I'm putting it in the right position. And then I read it out later and it's broken. Okay, I'm going to try another thing. This should be the equivalent thing that I was just saying. Okay, good. Whew. What? Where's my... Okay, there's my effects button. Tone generator. Let me make it so y'all can hear this. Okay. Let's pause here music. Now this should sound good. It should sound just fine. Yep. Which is funny because it sounds like it's folding back on itself still, but... That's fucked up. Okay. So what I just did... And Hagerman, if you're still here, you'll understand this. I immediately took my delay array, and I wrote to it in like position 0, right? And I write to it in position 0 here. And then, sounds like phase cancellation. Yeah, I'm not sure. The problem with it being phase cancellation is that it implies that there's 2 signals. And there's not... I'm never combining 2 signals. That's not happening. The thing that you just heard was I stuck the left signal also in the right. So both the right and left ears were getting the exact same signal. And they're, getting it slightly off each other, but so what I just did was I'm writing to the vector, writing to the array, and I'm writing it at position 0, and I'm immediately reading from position 0. Right? Correct? So now what's happening is... Okay. Let me try something dumb. This should break it. This should sound horribly awful. Something is wrong with reading. That's what's going on. And I don't follow. Before I let y'all listen to this, I'm just going to see if it sounds terrible or not. Yes, it does. It's so weird because it sounds like I hear the underlying tone. I hear multiple tones. I don't understand that. Yeah, it sounds like a sawtooth wave with a sine wave. All right, I'm going to grab another protein shake. Hold on. Thanks for hanging out, James. Ugh. It sounds like I have two signals, but that's not possible. It's literally not. That is literally impossible right now. Until I find out that it is possible and I've ruined everything. Ugh, sucks. And I've already looked to see if the read position is accurate, and it is. Can you console log the output values being pulled for sanity check to... Yeah, I have. You can. It's a little shitty when you do that. But they're definitely below... They're below 1. You look at the other code. I have the feeling that there's something with DSP just in general that I'm missing here. So, sample of Y0 is buffer index of Y0. Let's say we returned that as the output sample. And then they were adding in feedback. And then they made feedback sample is equal to sample. And they added that back there. And then they made sample goes out. Yeah, so I should be able to feed sample. I should be able to feed the red sample directly to the output. So there's something wrong with what's being read. Okay. So I guess let's it's hard. Yeah, let's debug it this. Let's try to debug it this way with a breakpoint. I don't typically like doing it this way, but I'm going to try. It's crazy that we've confirmed that the writing is proper, the reading is failing. But I've no idea what the hell I've done to make the read fail. Unfortunately, I only have about 8 more minutes that I'm going to be able to stay on because I have other stuff I have to do. And I will be away from stream for probably at least a week, if not a week and a half after this, because real life gets in the way. But we will stream again. Okay, now we have terrible sound. Now let's instantiate a breakpoint. And let's pull the audio editor back up so it hits the breakpoint. Yep. Okay. So now, let's see. Read position is 164. Wait a second. Num samples is 900. Okay. Okay, so we have a 4-second buffer, which I don't even remember where I instantiated that. I think that's a little weird. Let's find out where I put that together. No, it had to be before that. Sample rate, get total number of output channels. Oh. Okay. So then in the delay setup, what am I saying here? Huh. Okay. Okay. Hold on. Oh, wait a second. I don't know why it's doing that. This is really funny. I found something that's wrong. Or at least it appears to be incorrect. So num samples here is 192,000. And this is from audiobuffers.getNum samples. And the size I'm setting here is the sample rate. Sample rate should be 48,000. Okay, let's pull up the API. Because this is insanity. I'm missing something somewhere. Okay. Get num samples. Returns the number of channels of audio data that this buffer contains. Returns the number of samples allocated in each of the buffer's channels. Sample rate versus sample size is the values per second versus the total data structures record. Yeah, so like what I'm curious is is this... So think about in computer science methodology, think about when I say channel, what I'm saying is array, right? So in audio, you can either have, if you have stereo, you've got two arrays. You've got a left array and a right array. If it's interleaved, then it's a single array with every other sample being left and right, left and right, left and right, back and forth. So if I were to have an interleaved array, then it would be like you took a deck of cards and shuffled it, right? Where one's left, one's right hand, one's left hand, one right hand, except it's left-right channels. So it's not clear what I'm assuming here, and I think that my assumption is correct, is we're returning the number of samples allocated in one channel of the buffer, one channel of the audio buffer object. So the audio buffer object can have 3 channels, but we're just saying this is the amount of data in one of the channels. Or this is the amount of potential positions in one of the channels, which should be accurate. And especially because that 192,000 number doesn't make any sense because there's only 2 channels, period. Yeah. And 48,000 times 2 is not 192,000, I don't think. 96,000, right? So that's weird. What does set size do? Now I'm curious. Why is this not alphabetical? This is really confusing. Why? Why would you make it not alphabetical? Changes the buffer size or number of channels. New number of channels, new number of samples. So number of channels and number of samples. Okay. Like, this is how I expected it to work. I'm just a little surprised because sample rate's 48,000. So why is this returning 192,000? That's crazy. Where are we going? Oh, this is old code. Could this be a Reaper config? It is, but I know for a fact that it's like, we can try this right now. Like, I'm pretty damn well sure. No, so I would agree with you, except for the fact that, actually, shit, I could have just done it right there. Watch. We are going to figure this out. Because sample rate running at 192,000 would be ridiculous. It would break a bunch of stuff. Like, usually sample rates at max run at 96K. Okay, so now we got our breakpoint. So we're back at 192,000, right? So let's do add expression audio buffers dot get num samples. Oh, and I gotta go in just a second. That's 192,000. Why is that 192,000? Sample rate. Wow. Okay. Where did 192,000 of this sample rate come from? That's not even real. Was this added somehow? I'm very confused now. I've literally now never seen this happen. Hold on. No, go away. Bring back actual Reaper for me, please. There. Options. Settings. Request sample rate of 48,000. I know that's unchecked, but like default system device. Okay. Let's just apply